Before we get started with the presentation, we just want to let everyone know that Beamable's tools are best suited for game devs who are already familiar with Unity. Take it away, Chris.
Hello everyone. In this demonstration, I'm going to show how we can use Beamable C# microservices built on AWS in order to implement a simple loot box sort of thing. So we'll have this 60-second timer. It'll go down to 0, and when it gets there, the user will be able to click claim, and they'll get some stuff. But then they won't be able to claim it again until the timer goes down. And if the timer goes all the way down to 0, then the user will have to come and actually claim the box before we start the timer again. So in order to do this, we could do it locally, just all client side, but one, that's going to mean that people can find where we're storing that time value and change it and abuse the system. And two, this also means by doing it on the server, we have the opportunity to configure it later. So this is going to be a pretty good use case for Beamable microservices. So let's get to it. So first off, we need to create a microservice. So from the Beamable toolbox, we go to the microservices page, and I'm going to create a new microservice, and I'll call this lootbox service and create. Okay, and here we get our UI for our microservice. And so when it built that, we can go into Unity now and go to our Beamable folder, open up microservices. Here's our lootbox service, and we get right away a C# file that I'm going to open up, and let's just start editing our code. The Beamable microservice lives inside of a class, right? So we've got lootbox service. This represents the microservice itself. So an instance of this class effectively is going to be running on AWS that we can call. And the methods that we can call on it are marked by this client callable C# attribute. So the first thing that we're going to implement, let's say we want to get the amount of time left that a player has to wait before they can claim their loot box. So let's change our name to get time left, and let's say this returns a number of seconds. Maybe we'll do that as an integer. And we're going to introduce somewhat of an unrelated Beamable concept called stats, where we can store key value data per player. So maybe let's store a stat that is the last time that the player claimed the reward. And then we can do a little bit of math around UTC now and stuff to figure out how many seconds they have left, or maybe it's going to be 0 if it's ready to claim. So I'm going to go ahead and implement that code. Okay, so now we have a method that's going to return the time left, and it's based on this stat here called last claim time. So actually, let's pull this out into a constant. So we're going to access it again. All right, and now we want a method that actually lets people claim the thing. So let's say, great, we're gonna have another, let's just have an empty promise for now until we know a type. We'll call it claim. And this is also going to be client callable because we're gonna wanna access it from our client. All right, now we have a claim method and a time left method. And this is actually pretty much all the behavior we need so that people can first call this method and update their text that we're going to have. And then when that text gets down to 0, they can push the button, push claim, and it's going to give them their stuff and then reset some internal state. All right, back in Unity then. So I'm going to create a script. I'll call this, I don't know, lootbox controller. All right, so this is going to be some Unity code, code that runs on the Unity client that's actually going to communicate with our lootbox microservice and update the UI accordingly. Okay, so now we're at this place where we've got this UI code that actually talks to the lootbox service client. And if we take an implementation deep dive here and take a look at what this does, we can just look at this. See, it's auto-generated code, so it's a little gross to look at, but what we do here is we actually just send a request out to the lootbox service and to the method called getTimeLeft. And if we had any parameters, we'd actually serialize those and send them along. And then we deserialize the actual data type that we want to get back. So I think it's time to hook this up in Unity and give it a test. So my logic game element, switch over to my inspector and add in my lootbox controller and dig into the canvas and drag the time left down here and the button over there. And now the important thing is my microservice isn't actually running. We can see that it says local stopped and remote disabled, like it's not running anywhere. And just to kind of prove that to you, actually, if I switch over to a console and do a docker ps command, you'll see that I don't have any Docker images running. So C# microservices and Beamable, like what they are, we're actually talking about building Docker images and then running local containers for local development. So I'm going to go ahead and push play, and this is the first time I've done it, so it's going to pull down a base image that Beamable has provided for us. So maybe we'll skip ahead through that. Nope, that went pretty fast. And once it does that, it's going to go off and actually build the source code, and now it's going to boot up and actually run the user code. So now this is running. So if I switch back to my terminal and just repeat that docker ps command, see I actually do have a local image running. It's called my lootbox service container. And so from here, we're actually good to go. And so I will just run the game and we'll see what happens. And so now our time is ticking down. So actually something that we can always do in Beamable, let me drag in an admin flow right now just so I can then open up here, and I'm going to type in dbid. So in the console, this is my Beamable player ID. I'm going to get this just so I can kind of go in and scope out some data on this user. So you can see we're still counting down. So while we wait for that, I'm going to open the LiveOps portal. And here I can search for that player ID, and I can pull up that user account. And if I just skip down to the stats section and look for, and search for claim, yep, I can see this is the last claim time, and now we've actually got a stat committed. So let's switch back over here, and it looks like we are ready to claim our reward. So let's just make sure that if I don't claim it and I start and stop the game, that we're still going to see that we're ready to claim at the 0 second mark. Yep, we are. And you know what I also should have done is add some semblance of currency in here. So let me add in a currency HUD. So this is going to show how many gems we have on this player. So it should start with, I don't know, probably 0. Yep, so we have 0 gems, going to claim. And yeah, it looks like we have one more bug around our timing, but we went up by 50 gems and our loot box has started again. And so now if I switch back over to the stat value, you can see that it was like 2021-36. Let me just refresh the page and search for that again. Yep, and so now we have a different time where it used to end in 36. It was 2021-36, now it's 2023-12. So this is working. And so yeah, those are microservices, then those are running. So right now this is all local, and I can push claim and nothing happens right now. So a couple other things to just kind of dive into here. This is local, that's great, but we want to publish this. We don't want it to be running on our machine, we want it to be running on AWS. So go to the publish button, and we can see that we've got one service. We're going to give it kind of just the minimum resource account, and I'll drop a general comment for AWS demo, and I'll click publish. And so now behind the scenes, what's happening again is that we have to take that user source code and build it into a Docker image, and then we take that Docker image and we upload it to ECR, Beamable's ECR. Then we actually have to post some information to Beamable that says we want to turn on these services in production effectively. And so I think the step that we're on right now is the last part of the image upload. All right, so it finished, and there's some information in the log that it did. So now what we can do is actually go back to our portal, and instead of searching in the players section, we go to the microservices section, and we can actually see that we have a deployment turning on. So this is actually reaching out to Amazon Fargate and checking like, hey, we've registered a service and a task definition. Like, are there any tasks, like task instances? We know that there should be, so we're going to say we're in the status of deploying. But obviously it takes a little bit of time to spin up those resources on AWS. And then in this lower section, we can see that this is the deployment that we made. So actually from here, we can even make new deployment. So if we needed to disable our service for some reason, we could turn it off just from the live ops portal. I don't want to do that, so I'll cancel out. And yeah, let's refresh the page and see if this is ready yet. Yeah, cool. So now we're running. So what I can do now, just to refresh your memory, I'm still running a local container, but let me turn that off. So I'll stop my local service. So now it's not running. So if I repeat this command, and we're getting a little bit cluttered in here, but in this last section, we're not running any containers anymore. But still, if I run this, well, yeah, we're ready to claim. We probably need some better text here, but I'll go ahead and claim. We got our bug, and now we're counting down again. And you can see I got my gems. So we actually went off and made that network request. So we sent a request here. And let's take a look at that just even in the portal. So from here, actually, there are a couple things that we can see. So there's a logs page that we can go to. And this is going to show us just the service logs from the running image. And by default, we're only going to see info logs. So we get this one that says like, hey, we turned on. But if we enable debug, then we're going to see a much more verbose listing of all of the messages that have gone through. So yeah, we handle the message to claim, and we can actually click on that and we can view some of the information around. And this also allows people to log stuff as they're used to and then explore it from in here. So we get access to the logs, and these are actually just being forwarded from AWS CloudWatch logs. We can also go back and take a look at the metrics tab, and this is going to show us the CPU and memory utilization of our service. Sometimes these take a moment to kind of initialize, so maybe we'll come back to that later. And then the last thing that you can do from here, which is really powerful from a live ops perspective, is you can go to the docs page, and this will actually look at your APIs and give you an open Swagger definition for your endpoints. So we can actually get the time left, and we can even execute this from here. So I've got 60 seconds left now, but if I run this again, now I'm counting down so as we execute this. And if I try to claim, obviously we can't yet because the time's there, so we get back false. So this can also be really helpful to debug stuff, and you can even access this from the locally running one before. So back in Unity, you can always access local stuff here, and you can even just get hot links to those remote sections. So if I wanted to jump straight to the docs, I can click View Documentation, and it's going to bring me right to this page. All right, and for a little bit behind the scenes, our customers never see this, but this might be pretty interesting to take a look at as part of this demo. So here's the AWS console we all know and love, and if we actually head over to ECS, we can take a look and find our running services. So we maintain a private cluster for each customer. So this prod just denotes that this is a production level customer, not like an internal dev customer. And then this next number is their customer ID. So let me go find my customer ID by going and pulling that out of the resources file. So my customer ID is this. So let me come back to Amazon and just search for that. Great. So here's my virtual private cluster. If I take a look at this guy, I can see that I got one service for my loot box service. And if I even dig further into that, we will see that we have a Fargate spot set up here with sort of a weight balance of like, if this service ever needs to scale up, we're going to prefer Fargate spot, but we'll always have one dedicated instance just in case there's not a lot of traffic to it. So we can take a look and see that we do in fact have one running task. And then perhaps the last thing to point out here is that we do also set up auto scaling rules here. So we do that based on CPU utilization. So we'll scale up based on that. So yeah, that's a little bit behind the scenes on like, this is where these services are actually placed and that they are running on AWS, although all of this is abstracted away for our customers so they can stay entirely within the Beamable portal. Cool. So that's an overview of how to create a microservice, write some code that does some interesting things, modify some player state, then access that code from Unity using auto-generated clients, hook it up to some loose game behavior here, and then do a little bit of inspection with the LiveOps portal and take a look at the microservices.